Recording. Okay, so in this video, we'll go over the chemical properties of group 1 elements, okay, the alkali metals. Okay, so these are very important, and you should know about the common chemical reactions, the chemical properties of the group 1 elements, and the trends that uh, they follow as you move down with the group 1. So these are the chemical properties of the group 1 elements. So number one, elements in group 1 are very reactive. Okay. And they're so reactive that they will even react with oxygen, air, and water. So yeah, even if you'll place like a block of sodium or lithium or any element, if you place it outside in open air, it will start reacting with air to form an oxide, right? So that's why these elements are preserved. In order to preserve these elements and in order to stop them from reacting with oxygen, they are actually stored in oil. Okay, they're stored in oils like paraffin and or kerosene. Okay, so whenever you'll go to your labs, I don't know if you have labs. So whenever you'll go to the labs, so you'll see that if you have samples of sodium or lithium, they'll always take it out of a jar filled with oil, right? And that's because they're highly reactive with oxygen and air. We'll discuss the reaction, how they react with oxygen and air in a few moments. The second chemical property is that all group 1 elements react with water to produce metal hydroxide and a hydrogen gas. Okay, so this is the first reaction for the reaction of a group 1 metal with water, right? This is a general equation for the reaction. So M right here shows the metal, right? So we have the metal and then we have water, right? And the group 1 metal reacts with water to form the metal hydroxide and also releases hydrogen gas, right? So if you'll drop a piece of, say, sodium in water, it will react vigorously with water. It will produce an alkaline solution of that of sodium hydroxide, and it will also produce some bubbles. Okay, so you'll also see effervescence, right? I don't know if you're familiar with the term effervescence. So it's spelled like EFFER, effervescence. I don't know if the spelling is correct. This is a term that is used frequently in your exam as well. And it just means that there are bubbles forming as the reaction proceeds. So this is a general equation for the reaction. So for example, if you drop a piece of lithium in water, it reacts with water to form lithium hydroxide. And you also see bubbles of hydrogen gas. So for example, if you have a beaker and you fill that beaker up with water, and then let's just use a different color. So if you drop a piece of lithium in water, so it immediately starts reacting. Like it makes a lot of sound. In some cases, it will even catch fire. Okay, so you drop it in water, it will start reacting with water. It will form this alkaline solution of lithium hydroxide. This is an alkali. It's a basic compound, and it will also form a lots of bubbles, right? So hydrogen gas will also be released from the speaker. So hydrogen gas, what is the test? What is the test which I can do to just check if it's really hydrogen gas? You guys have any idea? कौन सा test कर सकते हैं to check if it's hydrogen gas? Okay, so the test that you do for hydrogen gas is the flame test. Because if for example, if you just hold a flame, if you hold a flame over this beaker, so the flame, so you will hear a popping sound, right? The flame will extinguish with a popping sound. That just shows that there is hydrogen gas being released uh, the, through the reaction, right? So all of the group 1 metals, they react vigorously with water and they form a metal hydroxide, right? They form metal hydroxide and they also release hydrogen gas, right? So for every group 1 metal, the reaction is literally the same. right? So even if you react sodium with water, it will form sodium hydroxide in place of lithium hydroxide, of course, and will release hydrogen gas. If you react, uh, let's say, if you react cesium with water, that's a very violent reaction, and you will form cesium hydroxide and you release hydrogen gas. Right. So if you react any metal, a group of metal with water, it will form the same products, right? The only difference is that the alkali will be different. Okay, so now let's predict the physical and chemical properties of group 1 elements, right? So the so as you move down the group 1, right? So if you have like group 1, so group 1, let's just write the elements in group 1. So the first element is lithium, then we have potassium, sorry, then we have sodium. Wait, okay. So we have the group 1 elements. Okay. So we have sodium, we have potassium, we have cesium, rubidium. Sorry, we have rubidium first. I think we have rubidium first, then we have cesium, and then we have francium, right? So as you move down this group, you should remember that these elements will become more reactive. Okay, they will become more and more and more reactive. This is the only trend for the chemical properties that you should know, right? So for example, if you would drop a piece of lithium in water, it will react, it will react with water, right? And it will react in an exothermic reaction, it will result in an exothermic reaction. But if you drop, say, a piece of potassium in water, potassium will react more vigorously with water as compared to lithium. Okay? Because as you move down the group 1, the reactivity increases, right? So potassium will react more vigorously with water as compared to lithium. It will be a faster reaction. The reaction will be faster, right? It will be violent. The reaction will be more violent. It will be more exothermic. It will release more heat. Okay. And in some cases, if you drop a piece of potassium in water, so the reaction is so violent that the beaker in which the reaction is occurring often breaks, right? Because it produces so much heat, right? And the potassium often catches fire as well, because the hydrogen gas, it starts reacting with oxygen. That's how that. So that's why it's always recommended that you wear goggles and you ensure safety uh, when you're handling the group 1 elements, right? So the reaction becomes faster, it becomes violent, it becomes more exothermic, and uh, yeah. So that's all for the chemical properties. So as you move down the group, the reactions, Jana, they become more vigorous. So, yeah, so the reactivity increases down the group, right? Okay, so uh, that's okay. Okay, so let's just go over the position of hydrogen in the periodic table. Um, that's not really important. So, yeah, so the electronic configuration of hydrogen is 1. Okay, so right here we will just talk about, just go over the hydrogen's position in the periodic table because it's always been controversial. And I think we were discussing yesterday as well that hydrogen is often placed in group 1. Okay. The reason being that hydrogen has only one electron in its outermost shell, and that's why it's placed in group 1, right? But we know that except hydrogen, all elements in group 1 are all metals. Okay. They all exist in solid state at room temperature. Okay. And they're all highly reactive with oxygen and water. Now, hydrogen doesn't react with water. Okay. It's not solid at room temperature, it's a gas. Okay. And it also is not soft because it obviously is a gas. It does not react with water. It's not a metal. Okay. And secondly, hydrogen is, you know, hydrogen does not conduct electricity, right? So it doesn't share it doesn't share most of the properties of the group 1 elements, right? So that's why most of the chemists they disagree upon placing hydrogen in group 1. So, yeah, and that's why you'll see in some periodic tables, okay, which are shaped like this, hydrogen won't be placed here. It will be placed somewhere here. अलग से रखा होगा hydrogen. Okay. So, and that's why the position of hydrogen in the periodic table is somewhat controversial. So we'll stop here.